Just real quick on system instrumentation, and it's, you can't really see the slide, because of the media. But this has a little telemetry system on it. Solar power, it's got a little solar cell on it, and so you can measure moisture. You can measure where the pivot is, angle, how fast the pivot's moving. You can measure the flow rate. You can measure pressures and have it sent to your cell phone or your laptop, and you can shut the pivot off if you want. So, yeah, these things, they're not terribly new, but they're not very common. You don't see them very often. And that's why this one here, I thought, oh wow, look at that. That was cool. So I took a picture of it. Last break. Keep going.
Should we take 5 minutes?
Yeah.
Let's take 5 minutes.
So here we are, and this is, as you can see, it's virtually the same as the drawing on the board there. Very similar. Just this is, one thing that's a little bit different about this is got a change in elevation. Okay, so I wanted to just throw this out that as you're measuring these pressure drops, you also have to measure any increases of pressure. So if this, quarter mile out here, if it's 40 feet, could be 40 feet less than the pumping place, you actually have gravity feed out to the end of the pivot. So you have to account for that too.
But then if it goes up the hill on the other side of the field.
Goes up the hill on the other side, you have to, okay, and there's a really fun technology that we use to get around that problem, and I'll show you, I'll talk about it.
So wait, are you analyzing that at every single sprinkler head? The drop in elevation or change in elevation? Or are you just measuring it to the end?
You always go with the last sprinkler. Say you've got a 40 PSI sprinkler. That's typical in a low pressure system. So 40 PSI, then as long as you've got 40 PSI here, you're golden. In a system that has elevation change, you definitely would have regulators in it to make sure that they're 40 PSI all the way along. So they're going to be happy. I think that they're plus or minus 5 PSI.
So those regulators then would control that your output isn't changing?
Downstream. Yeah. So there might be 3 regulators in there. But then, each sprinkler, you say, well, this is how much volume is going through the sprinkler from the catalog. And so you have to add all those up, and that has to add up to the volume that the pump is putting out. The pressure, say 40 PSI here. You have to calculate all these pressure drops all the way. If the pipe is the same size, you can just say, that much pipe, that size. All the little elbows and fittings and stuff. This loss here, this is vertical. Add those in, it's pressure. It's volume and pressure. And compare that volume times the pressure in horsepower or watts, probably watts, should be the size of that motor. Okay, so that's how those match up. Let's see, this one, this is another online calculator that I thought was pretty good, and that you could put in the size of the field, timer settings, how much of the circle, efficiency, field efficiency, and it'll calculate how many GPM you need. Okay, so that's just awesome, saves you a ton of time to, figure that stuff out. So here's your method. Determine water requirement inches. That's the ET divided by the field capacity. Calculate gallons per minute for the sprinklers. That's how much area the sprinkler is going to cover, and the rate that they're spraying. Okay, remember they're not all the same size. Either that or they're spaced closer together on the ends, out of the end. Select sprinklers based on the end of lateral pressure. Okay. Calculate all the lateral and pipeline pressure losses. Add the losses to that. I know I'm just reading the screen. Isn't that lame? It's getting late in the day. You should stop me. What are you doing? Okay, read the thing. Okay, and at the end of the day, you've got the GPM and pressure requirement for the pump. Okay, so this is how we relate the size of the system and the pressure drops and volume to the pump that we need. Okay.
You forgot one word on that.
Voila.
There you go.
Voila. What was the French word that we were laughing about the other day? I don't remember what it was now. French. They're not as fun as the Irish, though. Man, the Irish are fun to laugh at. Oh. I went to Ireland and stayed at a bed and breakfast there on the west coast. And I can't remember the name of this town, but the gal running the bed and breakfast says, so did you stop and visit any of your family when you went through Limerick? And I said, I don't know if I have any family in Limerick. And she says, you've got to have family in Limerick. Every third person's a Ryan. So then you know what the pump is, you know what the pump should be, so you can use at that point you can use the pump selection software to pick the pump, okay, and there's the manufacturers make the software, different software, and or you can ask the sales engineer to pick the pump. He hopes to sell a pump someday, he can help you do that. So, if you have an existing pump, you're doing an energy audit, you have the existing pump, then it's going to help you understand, is the pump too big or too small? Maintenance is really critical. Look for clogged screens. They'll have the intake, and sometimes these things will be clogged up. Sometimes they'll put a sprinkler in the pickup, and the sprinkler will keep debris out of the screen. Okay. Sometimes the screens will get plugged up, and so you'll see that the water in the ditch might be a foot higher than the water where the pump intake is. Okay, that's a foot. Okay, so you don't want that foot of loss, especially on the suction side. Okay, so be careful of that. Leaks, missing sprinklers, poorly designed or installed fittings. This is, the square corner thing. You will see those because, it's a lot easier to build that than it is to build a nice, smooth transition. Pumping cost, okay. This might not make it more efficient, okay? A fuel switch might not make it more efficient, but it might save a lot of money, okay? And so I think that when I go and do energy audits, I look at a lot of different measures, and so sometimes I'll pick a measure that's going to save them money, because then I'll be able to say, look, dude, if I save you $1,000 a year here, you can spend that savings on these other measures, okay? And buy down the cost of these other measures. And sometimes they go for it, sometimes they don't. Pumping efficiency improvements. Now, the whole idea is you're putting so much water on the field over some period of time. And so if you improve the efficiency, the whole idea is to put less water on the, to pump less water. And so it only works if you run the pump less time or you put a smaller pump in. So you have to really remember that, at the end of the day, what you're really trying to do is run the pump less or put a smaller pump in. Okay? So, look at the whole design and look for extra pipe that probably doesn't need to be there. They said, well, that's the way it's been, and I don't see any reason to change it. And there might, if you draw out, sketch the whole system, you probably see some efficiency gains just in the overall system. Yeah, err on the size of larger pipes and fittings. This is a tough one because larger pipes and fittings are expensive, and the farmer is not going to want to go to a larger pipe because the pipe is expensive. So you have to put it in terms of it'll pay for itself in a certain amount of time. Okay, get rid of elbows if you can. The suction side is really crucial. The thing about the suction line, pumps have a minimum suction pressure that they can work at. And if you don't give them enough suction pressure, then the pump will damage itself. Okay? And the way that the pump damages itself is it erodes. Because as the pump runs, the pressure is so low inside the pump that it actually makes bubbles. Okay? It makes steam bubbles inside the pump, and these bubbles, as they're formed and then they collapse when the pressure goes up, okay, they actually remove material from the impeller and from the inside of the pump, and so the pump actually wears out because of this. It's got a kind of a fun name. It's called cavitation. But and you can hear it. Okay, so if you have a really noisy pump, this is something that you say, this pump sounds like it's cavitating, it's making a lot of noise. Then you can start looking at the suction intake, seeing if it's clogged, seeing if there's something keeping it from flowing in there. Try to locate the pump as low as you possibly can. That's why these vertical turbine pumps, the pump is down there in the bottom of the pit. Submersible pumps, they're down in the well. Okay, that's why they're there. Is because you can't really suck water up any more than about 30 feet. So, give it a positive suction pressure if you can. Make water go down into the pump. Make sure there's, they should have a pressure gauge. They should have a pressure gauge on both sides of the pump. There should be a pressure gauge at the end of the pivot. And, more pressure gauges is probably handy, but those, I would say, those three locations at minimum should have pressure gauges. This is all in this. This is really good on the energy efficient pumping standards from Utah Power and Light, by the way. Engine improvements, tune it up. If a lot of these engines are old and they just have a fan belt and they've got a fan, running. If the fan doesn't have a fan clutches are cheap. You install a fan clutch, I think, on just about any fan. If you can take the fan off and put an electric fan on, thermostatically controlled electric fan. These are very common on cars nowadays. Now that they all have electric fans, and I don't think any car has a. I don't know. Anybody drive Dodges? Oh, okay, I won't say anything. No. Yeah, I think some cars might still have them. Motor improvements. Oh, okay. Or see, you've got all this water here. Take the fan off and just circulate irrigation water through the engine to cool it. Okay, this is pretty common actually. Motor improvements, rewind or replace. Yeah, it's the cost effectiveness of replacing a motor with the same size. It really has a long payback because they're really starting out. They're pretty efficient. Okay, so it's kind of not a really good energy saving measure. But if the motor has failed and you happen to be giving people advice about motors, you can say, well, replace it with an energy efficient motor, because energy efficient motors have a higher standard. They're more expensive, but the difference in cost pays for itself pretty quickly. Wrong size of pump or motor. Sometimes you can, if you make the impeller smaller, you can maintain the efficiency. So here's the best efficiency. You can maintain the efficiency, make the pump smaller, as long as you're satisfying the flow rate and pressure that you need. See, the pressure is fairly flat, these curves, so you can, you're not going to change the pressure a whole lot. And sometimes you can physically take the impellers out and take them to the machine shop and they'll trim them. And so, or you,
Reduces pressure?
what's that?
That reduces pressure? Or
It would reduce the pressure and the volume. Yeah. Cheaper than a new pump. This one, this was, anyway, you guys are probably terribly bored by now. This one, it always says the size of the pump. So they always say 10-inch little thing on the impeller. It shows what horsepower they require. It shows, this is the pressure, it's got a funny name, it's net suction head pressure that it wants. So thrust, I don't know about that.
So was this analysis on a system or just the individual pump like this?
This is just the pump, yeah. And this is, if the system curve is, let's see, if we're able to move the system curve within this high efficiency area, then we can get energy savings out of this pump. So the system, maybe we can replace a wheel line or hand line with a pivot. That's very common. Boy, it seems like we put a lot of pivots in here recently, last 10 years. Lots of new pivots out there. Equip, yeah, that's a pivot program. And if you have a high pressure pivot, you can put low pressure components on it. Install lower velocity, larger droplet size sprinklers. I put that on, but then it's like that depends on the soils, So if the soil is amenable to that kind of a thing, then you could maybe do this. And then replace the sprinklers. Like we said, 3 years, probably be worth it. Replace the sprinklers.